Hello everyone, welcome back to day 2 of 7.3. We still have a few more days to go. When we were talking about exponential expressions last time, we talked about simplifying exponential expressions. We talked a few things that expressions needed to have in order to be completely simplified. We needed no negative or zero exponents. That's a really important one that we'll actually start talking about in our next school day. All constants need to be simplified. That's actually going to come in handy today. And no duplicate variables. We'll see a lot of that today. So we are trying to get all of our variables all combined if we can, any constant simplified and combined, and then of course no negative or zero exponents. But the difference between yesterday and today, our essential question is just going to change a teeny tiny bit. But our essential question is going to read, can I simplify exponential expressions involving division? I'm going to be a little bit lazy here and put that division symbol there. All right, when we are looking at our division exponential expressions, you might see something like this. So let's do a little tiny review or some previous knowledge that you need. Our first thing is, would I ever accept that? No, I would expect you to do this and say, well, 4 goes into 4 once, 4 goes into 8 twice, so my answer is 1/2. You need to be able to simplify fractions. Another thing you need to be able to do is to simplify something like this, 5 over 5. Well, a lot of you are hopefully saying, well, I know that's 1, which is great, but you need to actually be able to write it out. So 5 goes into 5 once, 5 goes into 5 once, and that turns into a 1. And actually, I would like you to look at that pattern of 5 over 5 is 1. Well, what's 4 over 4? Well, that's 1. What is x over x? That's 1. And this is the key component of what we're actually going to talk about today. When you see a variable over a variable, like x over x, well, that equals 1. X squared over x squared is 1. When you see something like this today, 2x over 3x, and we look and we say, that's not simplified. I know because I have duplicate variables. And that's my goal. I've got to get rid of those duplicate variables. So if I have an x here and an x here, well, if we look really closely and we look at that ratio there, if there's an x and an x, I can start crossing them out. And I'm going to use a color, or you can use a highlighter. That's going to be really helpful for you. You're actually going to cross out that x turns into a 1, cross out that x turns into a 1, and then it kind of goes away. You don't write multiplication by 1. So 2 and 3 is your leftover. They kind of cross out and turn into a 1. Let's look at a similar one. How about this? So we're going to start seeing things. Firstly, like above here, we want to simplify any fractions that we see, if that's possible. So I look at my constants and I say, is there a way to simplify them or combine them? However, 4 over 8 can be simplified to 1/2 because 4 goes into 4 once, 4 goes into 8 twice. Now, is there anything else that's the problem? Anything else that's not simplified? And because there's 4 x's, there's lots of x's going around. And so you want to simplify that as best you can. X over x, those cross out when you see an x in the numerator and then x in the denominator. They cross out, they turn into a 1, and we just don't write that. We don't have to write multiplication by 1. And x crosses out and x crosses out. Again, another multiplication by 1. So then we go back and we say what's left over. Those x's crossed out and that turned into a 1. That 8 crossed out became a 2. Those x's crossed out and I have a y in the denominator. So that would be my simplified version of this original division exponential expression. And your next video is going to have a few examples.